Big hello again, everyone. Well done if you found this video on the Bradshaw Hall website. We're going to do a bit of a recap now of all the things we've covered in Year 6, some problem-solving questions. Here's the first one. Pause the video and have a go. Okay, so the first step to answering this question is realising that the actual number that you must have is bigger than 60. Because if you take half of the number here and a quarter of the number, in total that's 3/4 of the number. So 3/4 of the number is 60. Now, I know that this bit is double this bit, so I actually am going to split the 60 up into three pieces. Two of them in here, 40, one of them in here, 20, and that means that this block and this block are the same size. There's another 20, so in total I've got 40, 20 and 20, 80. Half of 80, 40, a quarter of 80, 20, add them together, that is our magic 60. Now have a go at these two questions. Everyone's favourite subject, algebra. For that first question, we have to look at the statement separately. K plus 7 is greater than 100. That means the smallest k can be is 94. It could be 94 or above. If it was 93, then k plus 7 wouldn't be greater than 100. If you have a look at the second statement, k take away 7 is less than 90. That means the most k can be is 96. If it was 97, I took 7 away, it wouldn't be less than 90. That gives us three possible solutions: 94, 95, and 96. Now, for the second question, I would suggest having a go at some different values for P and Q. Now, say if they were the same value, of course it would be 500 and 500, making 1,000. But there, P isn't 150 greater than Q. So you need to know that you need to make P bigger and Q smaller, so it still adds up to 1,000. Say if you had 600 and 400, well that's a difference of 200, so P must be a bit smaller and Q must be a bit bigger. Now, the key in the end is to split the 150 up into 75 and 75. If you add 75 to P and take 75 from Q, you'll have 75 more than the 500 and 75 less than the 500, meaning you'll have overall a gap of 150, but the numbers will still add up to 1,000. And here's your next question. Pause the video and have a go. The key here is to mark on what the smallest and greatest values are that fit in this box, and doing them as a fraction and as a decimal. So I can see, if I'm looking at it as a fraction, it's 1 1/4 at this end and 1 1/2 at this end. Whereas as a decimal, that's 1.25 the smallest and 1.5 the biggest. Any numbers in that gap then will fit. Well, 1.1, of course, would fall here. It would be less than 1.25. Whereas 1.4 is more than 1.25 and less than 1.5. 1 1/3 also fits in the gap, because of course 1/3 is more than 1/4 and less than 1/2. Whereas 1 1/5, well, 1/5 is less than 1/4, so that would be the other side of the line. Now, this question's eye-wateringly difficult. If you're feeling brave, have a go, and we'll go through the solution. Now, the first thing I would do is write it out algebraically. A representing the price of an adult ticket, and C representing the price of a child ticket. It's still not immediately obvious what the answer is, because in each formula we've got two variables, A and C. Now, if I know that one adult ticket and 4 children's tickets, £19, if I double that, I'll also know that 2 adult tickets and 8 children's tickets will be £38. Now, why would I need to do that? Well, it actually allows me to compare the formulas, because I know the only difference between these two is the number of children's tickets. They both have 2 adult tickets, but there's 2 children's tickets here and there's 8 children's tickets there. That must mean the difference, the 6 children's tickets, is an extra £21, the difference between £17 and £38. Now, if 6 children's tickets cost £21, to work out the cost of one, I'll need to do 21 divided by 6. How many 6s in 21? Well, 3, remainder 3, and I'll divide that by the 6, £3.50. Well done for getting to the end of the video. We're going to recap all that learning we've done this year in class over the next week or so, and we'll look forward to seeing you there.